this is the first of two questions from Chapter 3. Chapter 3 is on linear transformations. And so firstly they give us this particular transformation, which is called det, obviously short for determinant. And it takes a 2 by 2 matrix. M22 is the vector space of all 2 by 2 matrices with real entries. And it maps that space into the real numbers by simply taking essentially the determinant AD minus BC. And you want to check is det linear. And you might think initially, well, it probably is. It looks, that's a really common function, so you might think it is linear. So start off by checking what does it do to the zero vector, the zero object in this space. Does it do the right thing? Well, if you put 0, 0, 0, 0, you get det of that matrix is 0, and so it is mapping 0 to 0, so it's looking good. However, we should try perhaps do an example just to make sure that we're understanding what it's doing here. So let's just do a simple example here. So I'm going to take the matrix A to be 1, 2, 3, 4. That's a nice simple matrix. And if I work out det of A, well, that's easy. That's going to be 4 minus 6 is minus 2. Fair enough. Now, if this were linear, then if I, for example, double this one, I should get double that one. So let's just check. If I work out det of 2A, well, that's det of, when you double the matrix, you've got to double all the entries. And now we apply the formula, so we just take the determinant. I get 16 minus 24, and that's minus 8. And that's certainly not twice what we started with. So this is certainly not equal to twice the det of A. So, sadly, our det function is not linear. And that's all we need to do. Once you've got an example of where it doesn't obey the condition for linearity, then you're finished. It can't possibly be a linear mapping.